Hello students, this is the second video in the series of videos on the chapter properties of triangles. If you haven't watched the first video, link is available in the description box. You can have a look at it. In this video, we are going to look at the following topics: cosine rule, projection rule, tangent rule, half angle formulas, area and Heron's formula. If you are looking for a particular topic among these, there are timestamps available in the description box. You can make use of them. Moving on, let us start with cosine rule, also known as law of cosines. So it states that in any triangle ABC, we have a square is equals to b square plus c square minus 2bc cos a. Similarly, b square is equals to c square plus a square minus 2ca cos b, and c square is equals to a square plus b square minus 2ab cos c. So now we'll prove the first result. The other two results can be proved in a similar manner. For the proof of this, we'll start with sine rule, which we have seen in the last video. A by sin A is equals to B by sin B is equals to C by sin C is equals to 2R. We can also write this in a slightly different way, bringing this denominator terms to RHS. A is equals to 2R sin A, B is equals to 2R sin B, C equals to 2R sin C. Now let us start with this. A equals to 2R sin A. Squaring on both sides, we get A square is equals to 2R sin A whole square. Now we can write this as 4R square into sin A whole square. And now in a triangle, we know that sum of angles is 180. So A plus B plus C is 180. So replacing angle A with pi minus of B plus C, we get sine of pi minus of B plus C whole square. Now this can be written as sine of B plus C, because we know sine of pi minus theta is same as sine theta. So this is sine of B plus C whole square. Now using compound angle formulas, so sine of B plus C is sine B cos C plus cos B sin C whole square. Now using the expansion for x plus y whole square, we have square of the first term, square of the second term, plus 2 times product of these two terms. In this, what we are going to do is, we are going to replace this cos square c with sin square c with 1 minus sin square c, and this cos square b also we are going to convert in terms of sin square b, that is 1 minus sin square b. Now with this, what happens is, from here we'll get 2 terms, and from here we'll get 2 terms. The 2 terms, the first term here is going to be sin square b, the first term here is going to be sin square c. We'll get a sin square b sin square c term here as well as here. So the 2 terms will combine, we'll get minus 2 times sin square b sin square c plus, and this term as it is. Now from these 2 terms, we can take 2 sin b sin c common. Here you see 2 sin b sin c, 2 sin b sin c from these 2 terms. Now taking 2 sin b sin c common, what we get is here what remains is minus sin b sin c, and here we have cos c cos b. Now moving on, now you see cos b cos c minus sin b sin c. This is actually cos of b plus c, right? This is expansion for cos of b plus c. Okay, let us multiply 4r square with each of the terms. What we get is this one, 4r square sin square b, and so on. Now this can be written as 2r sin b whole square, 2r sin c whole square, and this whole thing can be written as 2 times 2r sin b, 2r sin c cos of b plus c. And this angle, in place of b plus c, we can write pi minus a. So we have this one. Now again using sine rule, this is nothing but b, and this is nothing but c. So we have b square plus c square plus 2bc cos of pi minus theta. Cos of pi minus theta is minus cos theta. So this is minus cos a. So hence we have a square is equals to b square plus c square plus 2bc times minus cos a. So this is nothing but a square is equals to b square plus c square minus 2bc cos a. So this is cosine rule or law of cosines. Now moving on, we'll see another way to prove cosine rule. So in this proof, we'll be taking help of coordinate system, and also we'll be using the distance formula. So let's say we have triangle ABC. Now let us choose the coordinate axis in such a way that origin is at vertex A and the side AB is along x-axis. So therefore this is x-axis and this is y-axis. So therefore the coordinates of vertex A are going to be 0, 0 and the coordinates of vertex B are going to be c, 0 because length of AB is c units. Now you see the side AC makes angle A with x-axis, that is side AB, and the length of side AC is b units. So therefore we can easily write the coordinates of vertex C as b cos A and b sin A. So now using distance formula, we can find the distance BC, the distance between the vertices B and C, and that is equals to A. So therefore we have A is equals to BC, that is equals to b cos A minus C whole square plus b sin A minus 0 whole square under root. Now squaring on both sides, what we have is A square is equals to b cos A minus C whole square plus b sin A whole square. So expanding this, we get b cos A whole square plus c square minus 2bc cos A plus b sin A whole square. Now the first term and the last term can be combined. So this will be b square cos square A, b square sin square A, and that will give us b square. So therefore we have A square is equals to b square plus c square minus 2bc cos A. So this is another way to prove cosine rule. So we have cosine rule, this one. This can be written in a slightly different way with cos A on one side, right? So for example, let us take 2bc to LHS and bring A square to RHS. So we have 2bc cos A is equals to b square plus c square minus A square, and bringing this 2bc to RHS, we have cos A is equals to b square plus c square minus A square upon 2bc. So in the similar manner, we can rewrite the other two formulas as well and obtain cos B and cos C. So this is cos A, b square plus c square minus A square upon 2bc. Now we can easily remember this. You see here if angle A is there, the side corresponding to vertex A, the side opposite to vertex A will be over here. The other two sides are here. Similarly, cos B is c square plus A square minus b square upon 2ca. Cos C is A square plus B square minus C square upon 2AB. Let us see a situation where these formulas can be used. Suppose if we, in triangle ABC, if you know two sides and the included angle, for example, if we know side B, side C and the included angle, we can use cosine rule, we can use this formula and easily find side A, isn't it? Because we know B, we know C and we know angle A. So we know all the three quantities. So using this, we can easily find side A. Once we have side A, we can use this formula and find angle B as well as angle C. Another case where this formula will be used is when we have three sides known. When we have three sides of the triangle known, we can use these formulas and find cos A, cos B, cos C, right? We can find, in other words, we can find angle A, angle B, angle C. Now let us move on to projection rule. So in any triangle ABC, projection rule says that A is equals to B cos C plus C cos B. B is equals to C cos A plus A cos C. And C is equals to A cos B plus B cos A. So this is projection rule. So now let us prove it. So we are proving the first result, that is A is equals to B cos C plus C cos B. We have taken the RHS. Now using cosine rule, we know cos C and cos B. Substituting in this, we'll get this. So cancelling B over here and cancelling C over here, we get A square plus B square minus C square upon 2A and this term. Now the denominator is same, adding the numerators. So B square minus B square will get cancelled, minus C square will get cancelled. So what we end up is, we end up with 2A square in numerator and 2A is in denominator. So this is it. This is equals to A, which is nothing but LHS. So this is one way to prove projection formula. Let us look at the alternative proof for projection formula. Now let us consider triangle ABC. Let us draw a perpendicular from vertex A to side BC. Now let us call this point as D. So in this right angle triangle ABD, so this is angle B. Now we can easily find BD. BD is nothing but projection of BA on side BC, isn't it? The horizontal projection. So in fact, the name projection formula comes from this. So this BD is projection of BA along the side BC, and DC is nothing but projection of side CA along BC. So now let us find BD. For finding BD, cos B in triangle ABD, cos B is equals to BD upon C. So from here we'll get BD is equals to C cos B. In the similar manner, in triangle ADC, which is a right angle triangle, so we have cos C is equals to DC upon B. So therefore DC is equals to B cos C. Now this is nothing but BD plus DC, which is nothing but BC. PC is nothing but side A. So therefore we have A is equals to B cos C plus C cos B. So in the similar manner, we can draw a perpendicular from vertex B to side AC and prove that B is equals to C cos A plus A cos C. Similarly, we can also prove that C is equals to A cos B plus B cos A, right? So here in this case, we have taken an acute angle triangle and proved these results. But we can also show these results for a right angle triangle as well as for obtuse angle triangles. I am leaving that as an exercise for the viewers. Now moving on, we'll see tangent rule, also known as Napier's analogy. So it is, in any triangle ABC, we have tan of B minus C by 2 is equals to B minus C upon B plus C into cot A by 2. That is this one. Similarly, we can write the other two formulas as well. So in place of B, C will come. In place of C, A will come in a cyclic form. In place of A, B will come. So we have the next one is tan of C minus A by 2 is equals to C minus A upon C plus A into cot B by 2. So whatever the angles are here, C minus A, so the same sides, the corresponding, the opposite sides are coming here, right? So the side opposite to vertex C, the side opposite to vertex A. Similarly, tan of A minus B is equals to A minus B upon A plus B into cot C by 2. So now let us prove this. Proving this is straightforward. Let us start with this term B minus C upon B plus C. Now using sine rule, we have this one. Let us replace B with 2R sine B and C with 2R sine C. Now cancelling 2R from numerator and denominator, we will get sine B minus sine C upon sine B plus sine C. Now again using transformation formulas, we have sine C minus sine D and sine C plus sine D formulas. Using them, we can write this as 2 cos B plus C by 2 into sine B minus C by 2, and this can be written as 2 sine B plus C by 2 into cos B minus C by 2. Now this 2 will get cancelled, and here you see this is nothing but tan of B minus C by 2, and bringing this cos in denominator, so this will become tan of B plus C by 2, this one. Now we also know that A plus B plus C is 180 degrees, so we can replace this B plus C with pi minus A. So this will become tan of B minus C by 2 upon tan of pi minus A by 2. This is nothing but, we can split it, pi by 2 minus A by 2, tan of 90 minus A by 2. That will become cot A by 2. Tan of 90 minus theta is cot theta. Now bringing this cot A by 2 LHS, we will get the desired result. Tan of B minus C by 2 is equals to B minus C upon B plus C into cot A by 2. We can prove the other two results in the similar manner. Now let us see half angle formulas. As the name suggests, we are going to find formulas for sine A by 2, cos A by 2, tan A by 2 and so on. So in any triangle ABC, we have sine A by 2 is equals to under root S minus B into S minus C upon BC, where S is semi-perimeter. So when we have angle A over here, the side opposite to vertex A is small a, we have the remaining two sides here, S minus B into S minus C upon BC. Similarly, sin b by 2 is going to be s minus c into s minus a upon ca, and sin c by 2 is going to be s minus a into s minus b upon ab, right? So easy to remember, whichever vertex is there or angle is there, the other two sides will be coming here, right? So next is cos a by 2. Cos a by 2 is under root s into s minus a upon bc. If angle a is here, it is s into s minus a, and denominator it is bc. So for cos b by 2 it is s into s minus b upon ca. For cos c by 2 it is root over s into s minus c upon ab. Now tan a by 2 is very straightforward. Just we'll obtain dividing sin a by 2 with cos a by 2. Just their ratio. So this is s minus b into s minus c upon s into s minus a, because the denominator is bc in both of them. So it will get cancelled. Similarly, we have formulas for tan b by 2 and tan c by 2. Now we will quickly see the proofs of this. So the proofs of this are very easy. We can actually derive all these proofs from cosine rule, and also one trigonometric identity, that is cos 2 theta. Cos 2 theta is equals to 1 minus 2 sin square theta, that is also equals to 2 cos square theta minus 1. So now using this one, we can actually find sin a by 2. So cos a is equals to this. We can also write this as 1 minus 2 sin square a by 2. Here in place of 2 theta we have angle a. So therefore this will become 2 sin square a by 2. Now rearranging this, we'll get 2 sin square a by 2 is equals to this. Now taking LCM, we have this 2bc minus of b square plus c square minus a square upon 2bc. Now rearranging these terms, what we'll have is, we have this. So this is minus of minus a square is plus a square. So we are writing a square over here. And 2bc term, so minus of minus 2bc is plus 2bc, right? So we can rearrange these terms in this form. Now this is nothing but a perfect square, b minus c whole square. So therefore what we have is this one. Now bringing this 2 to RHS, so this will become 4bc, and this is in the form of x square minus y square. We can write it as x minus y into x plus y. So you see a minus of b minus c into a plus b minus c. Now this is nothing but, so if you simplify this, a minus b plus c, this we can write it as a plus b plus c minus 2b. We are adding and subtracting b. This is nothing but a plus b plus c is nothing but 2s, because a plus b plus c by 2 is semi-perimeter s. So we can write a plus b plus as 2 times semi-perimeter 2s. This is nothing but 2s minus 2b. In the similar manner, this is going to be 2s minus 2c. So therefore we have 2s minus 2b into 2s minus 2c upon 4bc. So simplifying this, so we can cancel out this 2 and 2 will become 4. We can cancel that 4 in numerator and denominator. That's it. So we have sin square a by 2 as this. Now sin a by 2 is equals to plus or minus under root of this. Now to decide whether to take plus sign or minus sign. So now we know that in triangle, in any triangle, each angle will be between 0 to 180. So a by 2 will lie between 0 to 90 degrees. So which is a first quadrant angle, and in first quadrant sign is positive. So therefore we will choose only the positive sign, right? So therefore sin a by 2 is equals to root over s minus b into s minus c upon bc. So here we are going to use this one and this one. Cos 2 theta is equals to 2 cos square theta minus 1, and the cosine rule. So cos a is this. We can write this as 2 cos square a by 2 minus 1, and bringing this one to LHS and taking LCM, we'll get b square plus c square minus a square upon 2bc. Now rearranging the terms, we have this. This is nothing but b plus c whole square, right? So we have 2 cos square a by 2 is equals to b plus c whole square minus a square upon 2bc. So bringing this 2 to RHS, and also here we have x square minus y square. We can write this as x minus y into x plus y. So that is b plus c minus a into b plus c plus a. So we can write this as adding and subtracting a. We can write this as a plus b plus c minus 2a, which is same as 2s minus 2a, and this is nothing but 2s. So therefore this is equals to 2s minus 2a into 2s divided by 4bc. Now this 2 into 2 will be 4, that will get cancelled. Again we have cos a by 2 is equals to plus or minus root over s into s minus a upon bc. Again angle A lies between 0 to 180, so a by 2 is first quadrant angle, so cos of theta, where theta is first quadrant angle, so cos theta must be positive quantity. So therefore cos a by 2 is equals to root over s into s minus a upon bc. We can derive the other results in a similar manner. Now using these two results, we can easily derive the formula for tan. So sin a by 2 is root over s minus b into s minus c upon bc. Cos a by 2 is root over s into s minus c upon bc. Dividing these two, we'll directly get tan a by 2 formula. That is tan a by 2 is equals to sin a by 2 upon cos a by 2. So the denominator bc will get cancelled. We'll get this. And cot a by 2 is just the reciprocal of this, that is we'll get s under root s into s minus c upon s minus b into s minus c. We can also express these two formulas using area of triangle, which we will see after covering the area of triangle. Now let us look at the last section, that is area of triangle. So now area of triangle is denoted by delta. So now we know that area of triangle is equals to half into base into height. So now let us say this is the base and this is the height of the triangle. So if you drop a perpendicular from vertex A to side BC, right, so this way, so this is, let us call this point as D, this is angle B. Now the AD is called height and BC is base. Now base is nothing but A, and in right angle triangle ABD we can easily find sin B. What is sin B? Sin B is opposite upon hypotenuse, AD upon C. So therefore AD is nothing but C sin B. Therefore the height of this triangle, so when we take BC as the base, the height of this triangle is going to be AD. AD is nothing but C sin B. So this is C sin B. So now we know base and we know height. We can directly find area, that is half into A into C sin B, that is half AC sin B. Now using sine rule, we can replace this sin B as B by 2R, right? B by sin B is 2R. So we can replace sin B with B by 2R and this will become ABC by 4R. So this is another formula for area of triangle. So one formula is half AC sin B, another formula is ABC by 4R. Delta is equals to ABC by 4R. This can be written in different ways using sine rule. So now replacing C with the 2R sin C, we get this will be half AB sin C. Similarly, we can replace A as well as B and we'll get two more formulas. So this will be half BC sin A, half CA sin B. So in other words, if you look at these formulas, it is AB sin C. That means any two sides and the sine of angle between them, include angle, half AB sin C, half BC sin A, or half CA sin B. So that means product of any two adjacent sides into sine of angle included between them, into half. That will give us area. So therefore delta is equals to, so we can use any of these formulas depending on the data given in the question. Now let us derive Heron's formula, the famous formula for area of triangle. So we have area is equals to half BC sin A. Now we know that sin 2 theta is equals to 2 sin theta cos theta. Using this, we can write sin A as 2 sin A by 2 cos A by 2. So cancelling these two, we have BC sin A by 2 into cos A by 2, and now we know formula for sin A by 2 and cos A by 2 from the half angle formulas. So that will be BC into, this is sin A by 2 and this is cos A by 2. Here BC will get cancelled and we'll get the famous Heron's formula, delta is equals to under root S into S minus A into S minus B into S minus C. This is how we get area of triangle in this form. Delta is equals to root over S into S minus A into S minus B into S minus C. Now using this, as I said earlier, we can write the formula for tan A by 2 and cot A by 2 with the help of delta. So we have tan A by 2 is equals to root over S minus B into S minus C upon S into S minus A. Now multiplying this with root over s minus b into s minus c in numerator and denominator, we get this one. So numerator will be s minus b into s minus c and the denominator will be delta. That's it. And another way to write this is, we can also multiply with root over s into s minus c in numerator as well as denominator. So the numerator now will be delta and the denominator will be s into s minus c. So this is another way to write the tan a by 2 formula. So now cot a by 2 is just the reciprocal. So cot a by 2 is going to be delta by s minus b into s minus c or s into s minus c upon delta. These are more useful, especially in the questions. Tan a by 2 is equals to delta by s into s minus a and cot a by 2 equal to s into s minus a by delta. So that's it for today. Have a nice day.